Okay, now, this is a Le Chatelier's principle, so we need to think about what is going to happen as we manipulate this. Okay, so when it tells you an exothermic reaction, that means heat is a product, so go ahead and write that on there. If it says it's endothermic, heat is a reactant, put that on there. Okay, so let's think about this. If we add more carbon, so this is, we're going to say this reaction is at equilibrium, and then we add carbon. Carbon is a reactant, but it's solid. Does it have any effect on equilibrium? No. All right. Add more H2. H2 is a reactant that matters in equilibrium. So when we add more reactant, we need to make more products. So the reaction is going to go to the right. So you want to make more products, or you can say make products. Okay? If you raise the temperature, raising the temperature is the same thing as adding heat. If you add heat, in this case, heat is a product. So the reaction is going to go to the left. Now, you also have to consider the effect that, remember, K values are only valid at a certain temperature. So it's going to go the other way, and you're adding heat, so you're actually going to end up with a smaller K. Try not to waste too much brain power on that, but it does happen. Adding a catalyst. Does catalyst have any effect on equilibrium? No, it does not have any effect on equilibrium other than that you will reach equilibrium faster. Because we're not adding any reactants or anything. So we're just going to get there faster. Adding neon gas to the reaction. When you add an inert gas, it affects nothing. So an inert gas, meaning a gas that is not part of the reaction. If you added water vapor, not part of this reaction, it would have no effect. If it doesn't belong in the reaction, it's not going to have an effect. Same thing with a catalyst. A catalyst is not involved in this reaction, so it doesn't really affect the equilibrium. Now, if you lower the volume, think back to Boyle's law, PV equals nRT. All right, if you lower the volume, that means you have to raise the pressure. So when you raise the pressure, raising the pressure means you're going to have to look at how many moles of gas you have. Raising the pressure, we want to have fewer molecules of gas. The fewer molecules of gas are located on the product side. So the reaction is going to go to the right, where there are fewer gas molecules. Le Chatelier's principle is quite tricky, so just be careful and try to think it through. If you look at it and you go, I don't know how in the world this would affect it. You know, think about raising the temperature, heat's a product. All right, decreasing volume increases pressure. To keep things the same, we want fewer gas molecules because it wants to try to equalize that pressure again.